Canada is een land dat veel doet aan ruimteonderzoek. Ze hebben er zelfs hun eigen astronauten.
At first, the space race was a contest between the USSR and the United States. The costs of exploring space were so colossal, the superpowers were the only ones capable of launching such an undertaking, which was, above all, a matter of international prestige.
Clear the tower. Roger, tower clear. Roger, Tom, you got good thrust on all engines. You're right on the money. 30 seconds, we're on the way. Stand by.
Few people are aware that Canada was the first country to follow the USSR and the United States into space. It was also the first country, excluding the two superpowers, to design and build a satellite. The Alouette satellites were designed and developed by telecommunications research laboratories belonging to the Canadian Ministry of Defense. Besides demonstrating that Canada was developing its own expertise in space technology, the Alouette satellites had a specific scientific purpose. They had been designed to study the electromagnetic characteristics of the Earth's atmosphere. We know the upper layers of the atmosphere are bombarded by solar radiation, and the gases which form these layers are, as a result, electrically charged. These gases are responsible for the northern lights and help transmit radio waves around the Earth. Information about the ionosphere is an essential element in the development of radio telecommunications. The development of the first satellite to study the ionosphere from space further enhanced the solid reputation Canadian researchers already enjoyed in this field. If any one person is to be singled out as a pioneer of Canadian space technology, it would have to be John Chapman. In 1959, he proposed the idea of building the Alouette satellites. Until his death 20 years later, he was the principal driving force behind the development of Canada's space technology. On September 29, 1962, the Alouette 1 satellite was launched from the Vandenberg base in California aboard a Thor-Agena rocket. Four years of work and effort were tested. At the time, only 50% of the rockets launched reached their target orbit.
6, 5, 4,
Fortunately, the launching progressed smoothly, and the little satellite reached its orbit in perfect condition. Until then, satellites usually lasted no more than a month in space. The designers of the Alouette, however, set a goal of a year, while specifying they would consider 3 months a total success. The Alouette did even better. It relayed information back to Earth for more than 10 years, making it possible to study the electrical characteristics of the upper atmosphere through different seasons and through various types of solar activity.
Spacecraft ready. Spacecraft ready. NASA ready. Mission with NASA and... Check 17. Alouette B is ready for launch. On my mark, it will be T-minus 12 seconds. Spacecraft ready. Spacecraft ready. NASA ready. Mission with NASA and mission ready. We have a clear to launch. We have a green light. And our next right. Lift off.
Alouette 2 was launched on November 29, 1965. It too operated for 10 or so years and provided a great deal of information about the electromagnetic activity of the sun and how this activity affected the atmosphere and the transmission of telecommunication waves. Encouraged by the success of the Alouette program, the Canadian government developed the ISIS satellites. The 2 ISIS satellites were designed to continue the research of the ionosphere began by Alouettes 1 and 2. In the hope of laying a foundation for a national space industry, the contract for the construction of these 2 satellites was given to RCA Limited in Montreal. ISIS-1 was launched in January 1969, and ISIS-2 was launched 2 years later.
1, 0. We have commit. We have... That's clear.
The 2 satellites are still in operation today. From the outset, Canadian space technology has concentrated on telecommunications. This orientation is only logical because Canada is so large and sparsely populated. And satellites offer a powerful and relatively inexpensive way of serving large regions. In 1964, Canada was one of 11 countries to set up Intelsat, an organization established to operate a worldwide satellite telecommunications system. 5 years later, in 1969, Telsat was established. Similar to Intelsat, it was designed specifically for Canada. It was another world first. Anik A1 was the first geostationary satellite ever to be launched for domestic communication. It was to transmit telephone communications and television programs to all points in Canada. The first Anik satellite was launched on November 9th, 1972. The Telsat system was operational 2 months later.
10, 9, 8, 7, 6, 5, 4, 3, 2, roule d'eau.
1, 2, 1, 2. Oh, monsieur. Attention pour mixer la caméra 2. Bonsoir, mix à 2. Bonsoir.
Attention, mais vous silencieux avec cartouche numéro 1.
Actuelle dans les cégeps à travers le Québec. Et nous commençons ce soir par vous demander si les possible pour les chanteurs des
Roule 12.
ailleurs.
Attention, on ne va pas bouger comme moi.
Super j'ai peur qu'on ne m'aime pas. J'ai peur que l'on me prenne pour quelqu'un que je ne suis pas. J'ai mal, je suis en mal d'amour. J'ai mal à la devanture et j'ai mal dans le fond de la cour. Je suis comme tout le monde, j'ai peur du ciel et de l'enfer. J'ai peur que le soleil se tanne d'éclairer la terre.
Several more Anik satellites were launched, and Canada now has one of the most sophisticated telecommunications systems in the world.
Pour cette grande discussion par satellite, Jacques Pradel est à Marseille. Bonsoir Jacques.
Bonsoir ma chère Claire et bonsoir également donc de Marseille aux téléspectateurs du Canada et de la Suisse. Nous allons évidemment débattre avec le plateau donc français des mêmes thèmes que vous signaliez il y a un instant. Tout de suite, je vous propose Claude Terracinta donc de prendre l'antenne maintenant pour la Suisse.
Eh bien, bonsoir Jacques, bonsoir au Québec, bonsoir à la France, bonsoir à tous les téléspectateurs canadiens, français et suisses qui suivent cette émission. Bonsoir à nos invités qui sont ici dans ce studio.
In the hope of developing satellite communications technology even further, the Canadian government launched the Hermes project in 1971. The Hermes satellite was launched in January 1976. It was the most powerful communications satellite sent into orbit. Small 60-centimeter parabolic antennas can pick up the television signals relayed by the satellite. For 4 years, the Hermes was used to carry out a series of interactive telecommunications experiments in the fields which included teaching and medicine.
I'd like to have you set up the scope, Ellen, so I can look in his throat.
Hey, Mr. Garcia, can I have you open your mouth real wide? Well, the throat looks
Pretty good. It's not too red either.
From a technological point of view, the Hermes program paved the way for the new telecommunications satellites now appearing on the market.
Nous vous parlons de Strasbourg, où se déroule en ce moment le Congrès international de la jeunesse européenne. Un temps magnifique est au rendez-vous. Vous me recevez? L'un de nos participants, déjà une première question qui s'adresse aux jeunes Québécois.
Bob, apparently receiving audio video feed from Boston. This is Pat Egan. Just want to...
Many Canadian companies were involved in the Hermes program from the very start. The expertise they have developed has enabled them to offer their services both nationally and internationally. One of these companies, Spar Aerospace, has participated in the construction of approximately 50 satellites. Spar was the first Canadian company to be involved in building satellites. It has already delivered 2 Anik D satellites, which were launched successfully in 1982 and 1984. Spar also built 2 communication satellites for Brazil. They were similar to the Canadian Anik D satellites and were launched by Ariane rockets. Telsat Canada has ordered 2 new Anik satellites. They'll be built by Spar Aerospace at its factory in Montreal. On top of all that, Spar recently completed a $65 million contract for the European Space Agency. It manufactured solar panels and electronic components for the telecommunications satellite Olympus. The satellite was tested in laboratories at the David Florida Center of the Federal Ministry of Communications in Ottawa. Telecommunications technology has continued to evolve. To remain in the forefront, Canada is developing a new mobile communications satellite. The MSAT satellite will be able to convey local communication systems, such as cellular and radio phones. It will also serve firemen, policemen, and navigators. An ambitious project. It will cost over $300 million. Along with the United States, France, and the USSR, Canada has been involved in the International Search and Rescue Program, which uses the SARSAT COSPAS satellite. The program was launched in 1983. Canada supplied ground-based receiving stations manufactured by Canadian Astronautics of Ottawa. Thanks to this satellite surveillance system, planes and ships in distress can be located immediately and rescued. Canada is also involved in development and use of remote sensing by satellite. The Canada Centre for Remote Sensing in Ottawa is the hub of these activities. Until recently, Canada used images from American Landsat satellites. Now, they're relying increasingly on the French, who developed and have been using the SPOT system since the beginning of 1986. A receiving station for SPOT images has been built in Gatineau, Quebec. Some Canadian companies are active in this field. MDA, a firm in Vancouver, manufactures remote sensing receiving antennas and sells them all around the world. Canada is currently developing its own remote sensing satellite, RadarSat. This satellite will have radar, which will be able to provide detailed pictures of the Earth's surface day or night during clear or cloudy weather. RadarSat should be available by the early 90s and will be used for surveillance of ice fields, agriculture, and natural resources throughout Canada. The project is expected to cost more than $500 million. Even though Canada has struggled to develop expertise in the area of space technology, it has never considered building its own launchers. Canada is not ready to take on the technological challenge of developing powerful and reliable rockets. It would be almost impossible to make such an investment profitable on Canada's needs alone. Until now, Canada's satellites have been launched into space by American rockets or by the Space Shuttle. Canada, however, does have smaller rockets which can carry a payload of 200 kilos, as high as 700 kilometers. These Black Brant rockets are manufactured by Bristol in Winnipeg, and they're used primarily for meteorological and scientific experiments in the upper atmosphere. They are versatile research instruments, and NASA has bought and launched a large number of them. These rockets are not the only pieces of space equipment Canadians have sold to the United States. In the early 70s, NASA asked Canada to develop and construct the remote manipulators for its fleet of space shuttles. The manufacture of these remote control arms has been one of Canada's major undertakings for the space industry. The National Research Council gave the job to SPAR and CAE Electronics. The cost of developing the first prototypes came to more than $100 million. Even though the arm was designed to operate in conditions where there's no gravity, it had to be developed and tested on Earth. A special lab was constructed, and the arm sat on cushions of air to minimize any friction. A large portion of the design was done on computers. The remote manipulator is like an arm, only it's 15 meters long. It was modeled after the human arm. The astronaut, sitting comfortably inside the capsule, sends instruction by computer to the arm, which obeys those commands instantly. Although it would not be able to lift its own weight on Earth, in space, it can play with loads weighing more than 30 tons. The Canadian space arm was first tested in space on Columbia's second flight in November 1981. The arm was also used in an attempt to repair the SolarMax satellite in February 1984. The following November, it was used to recover 2 more satellites. It has always functioned perfectly and is now an essential component of every American shuttle. Like other countries, Canada is also aware that space cannot be conquered without people. In response to an invitation from NASA, the Canadian government began to train a team of astronauts. The National Research Council was responsible for recruiting and training Canada's first astronauts. They recruited people in 1983 and 1984, and out of 4,000 candidates, 6 astronauts were chosen to carry out Canadian experiments in space. The first series of experiments shed light on the problems caused by weightlessness. The purpose of the second series of experiments was to develop a system of artificial sight for the shuttle's remote manipulator. Such a system would make the arm more accurate and agile. It would no longer operate as though it were blind. In October 1984, Marc Garneau became the first Canadian to go into space. As dawn broke, the shuttle Challenger left the ground and headed towards the sky. In anticipation of other missions by Canadian astronauts, Marc Garneau conducted a series of tests concerning weightlessness. He then completed numerous other experiments in a variety of scientific fields. Canada's first astronaut also took pictures of the launching of a small satellite. These pictures will be used in the development of the future artificial sight system for the remote manipulator. Canada agreed to participate in the American Space Station program to keep the door to space open. Canada intends to invest more than $800 million in the space station, which should be built by the mid-90s. Canada will be in charge of building the maintenance center for payloads. Like a garage for the space station, this module will be used to make repairs or modifications on equipment used in space. It will also serve as an exterior workshop for astronauts using 3 remote manipulator arms. In the hope of coordinating these programs, the Canadian government is going to establish a national space agency. This agency will be responsible for planning Canada's space program. "25 years after launching the Alouette, Canada is embarking on a new era of great achievement in space.